All right, guys, today we are going to keep on going with finding the area of these quadrilaterals. And today we are going to start with the area of a kite and a rhombus. So when we do this, these two are going to actually have the same formula for area. What we're going to do is we're going to have our area equal to 1/2 our diagonal 1 times our diagonal 2. Or sometimes you'll see me write it as diagonal 1 times diagonal 2 divided by 2. So let's take a look with kind of where that comes from. So the first thing we want to look at is the diagonals of each of these shapes. So if I draw in my diagonals for each one, and I'm going to label diagonal 1 and diagonal 2 on each one. Now, if I wanted to find the area of each of these shapes, let me go ahead and switch colors really quick. What I can do is I can take these right triangles. So remember, in a rhombus and in a kite, our diagonals form 90-degree angles. So if I take these right triangles created on the bottom side of each shape, and I move them to the top kind of corner here, so I move them up here, we can see that we have now created rectangles with each of these shapes. And in this rectangle, I have a length, so the long side has a length the same as my diagonal 2, and the height of both of these is half of the length of my diagonal 1. So if I'm looking for the area of these new rectangles that I created, both here and here, what I can do is I can do my 1/2 diagonal 1 times my diagonal 2, because that's the same as doing my length times my width. So let's go ahead and try these here. So number 12 says find the perimeter and area of the rhombus below. And we're given that one of the diagonals is 14 inches and one of the side lengths is 25 inches. So let's think about, if I'm looking for the area, I know I'm going to need my second diagonal. So I'm going to draw the second diagonal here across. And if I have a rhombus, I know that consecutive sides are congruent. So all 4 of my sides here are going to be congruent. So when I'm finding the perimeter, if I have 4 congruent sides and I know that they are all 25 inches, I can do 25 plus 25 plus 25 plus 25, which is the same as 4 times 25, or 100 inches. So when I add all those sides together, I get that my perimeter is 100 inches. Now, if I wanted to find the area, I need to figure out what this diagonal here is. Well, if we remember, in a rhombus, our diagonals are perpendicular, so I have a right angle here in the middle. I also know that my diagonals bisect each other, so I know that each side of my diagonals are going to be congruent. So if I want to look at just the top right triangle that's created with my diagonals, I know that one of my legs is going to be 7 inches because it's half the length of the diagonal that was given. What that means is now if I'm looking for the other diagonal, I need to find half the length of my other diagonal using this right triangle. Well, to do that, I can use my Pythagorean theorem, and I can say that x squared plus 7 squared equals 25 squared, or x squared plus 49 equals 625, x squared equals 576, and then I can take the square root of both sides and get that x equals 24 inches. So if x is 24 inches, and that's half of my diagonal, then I know that my full diagonal is going to be 48 inches. Awesome. So now going back and finding the area, I'm doing diagonal 1 times diagonal 2 divided by 2. Well, I was given that one of my diagonals was 14. I found that my other diagonal was 48. And then I'm dividing by 2. And when I type that into my calculator, I'm going to get that my area is 336 inches squared. So my perimeter was 100 inches and my area is 336 inches squared. Awesome. So number 13, we're looking for diagonal 2 of the kite, where we have an area of 187.5 meters squared. And we're given that our diagonal 1 is 15 meters. So I'm going to look for this diagonal 2 created here. Well, I know that area equals diagonal 1 times diagonal 2 divided by 2. I'm given my area, so I could substitute 187.5 equals, I know diagonal 1 is 15, so 187.5 equals 15 times diagonal 2 divided by 2. So now I just want to solve for my diagonal 2. So I can multiply both sides by 2 and get that 375 equals 15 times my diagonal 2. Divide both sides by 15 and get that diagonal 2 equals 25 meters. And that's all that this problem asked us to do. So we are done. So what I want you guys to do now is I want you to pause the video and try number 14. So this one is a little bit harder than the first two that we did, but I want you guys to go ahead and give it a shot. Try to find the perimeter and the area of the kite. And then once you've tried that, then go ahead and keep watching the video and I will work through this problem with you guys. All right, so finding the area and perimeter of this kite. So since we know it's a kite, we do know a couple of things about it. We know that 2 pairs of consecutive angles are congruent, or I'm sorry, consecutive sides are congruent. So in this kite, I'm going to know that I have 2 sides congruent and my other 2 sides are congruent. So my 2 long sides and my 2 short sides. I also know that my diagonals are perpendicular, so I'm going to have 90-degree angles in the middle here. Okay, so if I wanted to find the perimeter, since I know that I have sides congruent, my perimeter is going to be 2 times one of my sides plus 2 times my other sides. So I would have my perimeter equals 2 times 41 feet plus 2 times my 15 feet. And when I plug that into my calculator, I get that my perimeter is 112 feet. Perfect. All right, and for the area, again, I'm thinking diagonal 1 times diagonal 2 divided by 2. And in a kite, if we think back to our properties, I know that one of my diagonals is bisected. So this short diagonal here is going to be my diagonal that's bisected. So one part is 9 feet. Then I know that my other part is also going to be 9 feet. So I'm going to call this short diagonal diagonal 1. So I know that diagonal 1 is 18. And diagonal 2 here is going to be my x plus y. So I'm looking at that long diagonal. That's going to be diagonal 2 and is x plus y. So now I have to figure out what are x and y. Well, if I think about these as triangles, I have one triangle here that has, and I'm going to redraw that triangle. I have a right triangle with one side being 9, my hypotenuse being 41, and my other leg being x. So what I can do is I can do my Pythagorean theorem, and I could say that x squared plus 9 squared equals 41 squared. I square everything, I get x squared plus 81 equals 1,681. I can subtract 81 from both sides and get 81 equals 1,600. And I can get that x equals 40. Okay, now I can look again at one of my other sides. So I could look at this bottom right triangle that's created. Again, I'll redraw it so we can see it a little bit better. I have my hypotenuse is 15. One of my legs is 9, and the other leg is y. So again, I could do my Pythagorean theorem and say that y squared plus 9 squared equals 15 squared. So y squared plus 81 equals 225. Subtract 81 from both sides and get y squared equals 141. And when I take the square root, I get that y equals 12. So thinking back up here to my diagonal 2 is x plus y. So if I do 40 plus 12, I get that diagonal 2 is 52 feet. So going back to my area formula over here, I get the area is diagonal 1, which is 18, times diagonal 2, which we just found to be 52, divided by 2, and I substitute that into my calculator, and I get that my area is 468 feet squared. All right, guys, that is all the practice that we are going to do in our notes for today. You guys do have a homework assignment that just like the ones you guys were doing last week, where we're just going to keep on practicing. And then tomorrow you guys are going to take a formative that covers these first few area formulas. Please let me know if you guys have any questions, and have a good rest of your day.